Alright, objectives for today. Summarize three factors that will affect whether rock melts. Describe how the cooling rate of magma and lava affect the texture of igneous rocks. Classify igneous rocks according to their compositional and texture. And finally, describe intrusive and extrusive igneous rock structures. Igneous rock forms when magma cools and solidifies. Remember, magma is below ground, lava is above ground. Three factors that affect whether the rock melts: temperature, how hot it gets, pressure, what's squeezing down on it, and is there any fluid in the rock? Water, mainly, is the main important one. Rock melts when the temperature of the rock increases to above the melting point of the minerals in the rock. So as soon as those temperatures get above that, then you start getting the rock to melt. Pretty makes sense, I guess. Rock melts when the excessive pressure is removed from the rock that is hotter than its melting point. So, when we did states of matter, I had you all stand in the gym, remember, and you were staying real close, then you spread out a little bit, you had to still be touching, then you can move all around the gym, or you might have been in the lobby, depending on which one you were. But one of the things I said, if I was to have you all stand together and then tie you with a rope where you could move, that would be what it's like being under that extreme pressure. The minute you relieve the pressure, you can spread out. But that pressure is just like that rope tying you guys in place and not allowing you to move around a lot. When we add water, such as a fluid to it, sometimes they decrease the melting point so the rock will melt faster. Partial melting. Different minerals have different melting points, and minerals that have lower melting points are the first minerals to melt. Seems pretty common. Think back to our ice cream sundae. We had the whipped cream, the ice cream, and the chocolate. The whipped cream would melt first, the ice cream would melt second, and the chocolate would melt third. As the temperature increases, each mineral melts in order, and you get that stuff mixed together. So now you have creamy whipped cream mixed in with your ice cream, so you get a creamier ice cream. And then if you had vanilla ice cream, for instance, and that chocolate melted, now you're putting chocolate into it. So you're going to change the composition of what makes it up. When you look at that process, that's called partial melting. Now, when we go to the point where we had it all melted, then we take it, put it back in the freezer. The crystalline shapes form according to reverse order of the way they melted. So again, the first one to come back would be the chocolate chips. And that's the last one to melt, first one to freeze. Chemicals of magma form different minerals, and each one has its own melting point and crystallizes first. That's called fractional crystallization. Here's a diagram. Go across. The yellow things in there are quartz, the gray are feldspar, the biotite is brown, the hornsbund is green. And as you go through each one, go from left to right, as each one melts you get more of the liquid surrounding those chunks. The last picture on the right would be like the ice cream and the whipped cream melted, but the chocolate chips floating around in there, the big chocolate chunks floating around in there. Now if we reverse that and we put it back in the freezer, you're going to get all those things back in order the way they melted. So you'll have the whipped cream or the chocolate chips back first, the ice cream back second. Excuse me. Oh, I'm sorry. And then the chocolate chips would come last, or the whipped cream would freeze last. Now, how a rock feels, that's called its texture. And we get that texture according to where the magma cools and hardens. Now, first two words you're going to need is intrusive and extrusive. Intrusive means it came up through underneath the, or they formed under the Earth's surface. Extrusive means it formed above the Earth's surface. Sorry about that, my dog kicked the door and scared me. It formed above the surface. The texture of the igneous rock is determined by the size of the crystals in the rock. So the size of the crystals is determined mainly by the cooling rate of the magma. So the longer it takes to cool, the more it's going to, hi Finn, the more it's going to, there, you want to say hi? Here, look. Oh, I'm sorry, I didn't mean to hurt you. Look at the camera, look up here. Can you look up here? Okay, sorry, we're pausing. The texture of the igneous rock is determined by the size of the crystals in the rock. The bigger the longer it takes to cool, the bigger the size of the crystals. If they cool slowly, you get those hard, coarse-grained igneous rocks. So, sorry, the dog's still here. I'm petting him. You get those well-defined mineral grains, and that has a coarse texture, so it's real rough to feel. Fine grain means it cools rapidly, and it's small grains, so you'll get a smoother texture according to the smaller grains, the smaller crystals of it. Sometimes you'll get a mix, and that mix means it starts to cool slowly, so you have these big large crystals, but then it cools much faster and these smaller crystals form. That's called porphyritic texture. Porphyritic means that it has a mixture. Sometimes when magma cools real slow, crystals will grow, and you get that small amount of dissolved gas, and that gas busts out of it, and then you get a glassy texture. That's called, we get things like obsidian, which is volcanic glass. If you get a vesicular texture, that's when you get that air bubbles trapped in there, and those gases will bubble out, and when it bubbles out, you'll get what we call pumice. Pumice is one of those rocks that there's so many trapped bubbles in there and leave holes in the rock that it becomes less dense than water and will actually float. It's kind of cool. Here's your first reading check. Please pause, and when you pause the video, then you can go ahead and answer the question, then come back. Okay, what's the difference between fine grained and coarse grained igneous rock? Fine grained forms from magma that cools rapidly, coarse grained from magma that cools slowly. Pretty easy concept. You can just see the top of your head, that's all you can see, And your breath stinks. Alright, mineral composition of an igneous rock is determined by the chemical composition of the magma from which the rock forms. So if you have depending on what's in the magma, that's what you're going to get the igneous rock. Makes sense. If it's in the magma, hardens into the rock, that's what it's going to be. Felsic is the first one. Felsic is an igneous rock that is rich in feldspar and silica, generally light in color, so it has a very light color to look at. Common minerals in felsic rock include potassium, feldspar, and quartz. Okay. And here's some rocks. They're granite, which like my countertops are made of, rhyolite, obsidian, which is volcanic glass, and pumice, which I told you floats in water. So they're pretty unique. Mafic. Now mafics are much darker in color, have a lot of magnesium and iron, and some include pyroclast, feldspar, and proxenes. And you get basalt and gabbro. Get out of there. Stop it. Finally, intermediate rocks, of course, there's always one in the middle, and these are rocks that have a lower proportion of silica, but they don't have enough higher proportion of the other rocks to be in the other one either, so they're just hanging out in the middle. You get diorite and anzonite for those. That went pretty fast, so I'll put that in my phone again. Diorite, anzonite. Andesite, sorry, I said anzonite, andesite. Now, we're going to give you some definitions of things, and basically they're going to have very small changes that you need to know the difference of to get what you want. So in this first one, you have batholiths and stocks. Batholiths are intrusive formations, remember that means they're formed under the earth, that spread out at least 100 kilometers squared when they're exposed to the Earth's surface. Whereas stocks are similar, they're the same thing actually, not even similar, they're the exact same thing, but they do less than 100 kilometers squared at the surface. Okay, laccolith is when we have a formation of layers of rock, all these layers form, and then the lava squeezes in between, and as it squeezes in between layers, it actually pushes up the rock layers and makes a dome. Okay, what's the difference between stocks and batholiths? Please go ahead and pause and write those down. Okay. Okay, batholith is an intrusive structure that covers an area of 100 kilometers squared. The stock covers less than 100 kilometers squared. Pretty common again. Sills and dikes. Okay, now, again, we have those layers of rock that form, and magma that squirts in between them, and forms in between them, but this one, in this case, it doesn't push up and form a dome, it just squeezes in between them and hardens. That's called a sill. Now, in those same layers, if the rock, instead of going with the layers, goes parallel to them, it goes perpendicular, cuts across the layers, that's called a dike. Okay? Only difference is, dikes follow the fractures that are already in the rock. We talked about fractures forming from a number of different things, mainly pressure relief. And they can vary in thickness from real small to great big giant ones. Take hundreds of meters up. Igneous rock masses that form on Earth's surface are called extrusions. A volcano is an example of an extrusion. We have volcanic cones and volcanic necks are common examples. Remember though, when I think of volcano, I always think of the mountain that comes up in the cone. Not all volcanoes are that way. Okay, enough. If there's a crack in the ground and magma and gas is coming out, then that is a volcano. Lava flows, lava plateaus, tuff layers are all common extrusions. Pretty common around those, especially around the highly volcanic areas. And here's a video, if it plays. and I have no idea why I won't play, but I'll play it at school. Okay? Thank you. Hope you enjoyed it.